You do not in there, but she does some.
That's why I'm not taking it.
Okay. Talk to me on this one. I don't remember. What page was it? Page 6? Is that a 5 or a 6? This one? And it was B? That's what you said. Okay. So it said find the function whose graph is a parabola. You have to have that, okay? Because otherwise you don't know what standard form to plug into. So that's why I typically say find the equation of the circle, or find the equation of the parabola, or find the equation of a cubic that's been shifted this many, okay? So this one's a parabola, which means the parent function is what? Parabola means it's a square, x squared. All right, so y equals x squared is the function that's somehow changing, okay? The standard form of the parabola or the quadratic is what? Y equals a times quantity x minus h squared, yeah, plus k. You need to know that. You need to know that. That is really important. Just like the equation of a circle, that is a standard form of a parabola, okay? A means it's been stretched or compressed vertically, all right? H and K are the vertex. You'll notice when it's in grouping symbols, it has a minus, but that's because it always changes the sign, right? So if H is positive, I'm going to see a minus in parentheses. If H is negative, minus a negative makes it positive, okay? So now I'm going to read it. It says, find the function whose graph is a parabola with vertex 2, -1. So that's my H and K. It's kind of like the center of a circle was H and K, but now it's the vertex. And then it contains the point 4, 2. So we're going to call 4 and 2 X and Y, okay? X and Y, just like that, all right? So now you just plug it in, and the only unknown you'll have, if you plug in H, K, X, and Y, the only unknown will be A. So I'm going to plug in Y. Y is 2. A, I don't know. That's what I'm trying to find, okay? X is 4 minus H is 2 squared, and then plus K is -1. So plus -1, okay? And now we're going to solve for A. So order of operations, PEMDAS, right? Parentheses first. 4 minus 2 is 2. Okay. E stands for exponents. Plus a minus just becomes negative. E stands for exponent, right? So 2 squared is? 2 squared is 4. And I like to put the 4 in front of the A. That's just a preference. You don't have to, but I like to. And now we're trying to solve for A, so we would add 1. Okay. 2 plus 1 is 3. Last step to solve for A would be to divide by 4. So 3/4 equals A. And now the last step is to now plug in A and plug in your vertex to get the standard form. So that's going to be Y equals 3/4 times quantity X minus 2 squared. And then can I just put -1? Everybody okay with that? Instead of plus -1 and then -1. Then that's your answer. Questions on that? Any questions on that? So has this been stretched or compressed vertically? Depends on what A is, right? So let's look. Let me prove I'm not anti-calculator. Y equals, okay? What would the parent function be? The parent function is x squared, yes? Okay, so x squared. You agree? So I said when it has that leading coefficient, that is either a vertical stretch or compression. I like to do this with my hands. Imagine pulling Play-Doh or something, stretching it, right? Compression means compressed, smushes, right? So if I put that fraction in, right, I can do alpha y equals, and hit enter. It creates that fraction. Did everybody just see what I did? Alpha is the green button, then y equals, and it gives you that fraction. 3/4, right? And then x squared. So what color is the original? Blue. Everybody see that? Okay. Can't really see what's happening super much, can we? Do we need all those negatives down there? Those x's? No. So I might make my window, I don't need those y values, so I might make it go from negative 20 to positive 20, and then make this be negative 1 maybe, and make my y values also 20, and now graph it. So look, which one was the original? Blue. So is it squashed? Is it wider? Or is it stretched and skinnier? It's compressed, it's wider, it's been smushed, right? Did you ever do that? Like roll a ball of Play-Doh and then smush it? It gets wider when it's compressed, okay? So you're probably going, yeah, but that's not the original. Well, I could graph the original. If it doesn't have a compression and it has that vertex, what would it be? It'd be parentheses, x. Y'all tell me, what was the vertex? 2. So minus 2, and then I square that, and then minus 1. Do you agree? Okay. Let me get rid of this one, actually. And then we said it had that compression, right? So I put in alpha y equals 3/4, and then I'm going to use that vertex, so x minus 2 squared, and then minus 1. Red is going to be without the compression, okay? Green has the compression. Ready? I'm going to do, I'm just going to graph it like that. Do you see that it's wider? It looks like it's been compressed, smushed. Watch what happens if I change that y equals from a fraction that's less than 1. Did everybody just hear me? I'm going to change that from a fraction that's less than 1 to a fraction or a whole number bigger than 1. Watch what happens. I'm going to make it a 3. Everybody okay with that? Does it look like I took that red one and stretched it, pulled it vertically, made it skinnier? Do you see that? So I just said something really helpful to you. I'm going to say it again in case you didn't write it down or you didn't catch it. When it is a fraction less than 1, it is a vertical compression. It makes it wider. When it is a number bigger than 1, that can be a fraction. 5/2 is 2.5, right? So when it is a number bigger than 1, it's a vertical stretch. It makes it skinnier. It pulls it skinnier, okay? And that's because when you find your y value, it's going to be multiplied by 3 or multiplied by 2 or whatever that number is that's bigger than 1, okay? Everybody good? Okay. When it's a number less than 1, it's compressing it. It's making it wider. Imagine compressing something, smushing it, okay? But when it's a number bigger than 1, which can still be a fraction, okay? It doesn't have to be a whole number. But when it's bigger than 1, it's like pulling Play-Doh. It's making it long and skinny. So it's going to make it skinnier, okay? All right.